Good morning, Pre Algebra. We are wrapping up Unit 2 with our last objective, CO12. I can estimate the square root of a number and locate its value on a number line. So we're working with those square roots that we learned about yesterday. This time we're estimating our square root. When would we estimate a square root? What kind of numbers did we work with yesterday? Tatum?
Like when it doesn't go even.
Yeah. Yesterday we were working with perfect squares, my favorite numbers. Perfect squares. So that means we can find that square root as a whole number. Now we're going to have numbers in that square root sign that are not perfect squares. So we have to decide, we're going to estimate it's about what? So you need to know your perfect squares to help you with your estimating. So you're going to be referring back to yesterday's objective page. So the area of a square is 25 yards squared. What is the measure of its sides? What would the measure of its sides be? If the area of the square is 25 yards squared, what is one of its side lengths, Hugo?
5.
How do you know that?
Because if it's 25 squared, you do the opposite operation, which is radical.
Yeah, because we know to find the area of a square, we take the area equals the length times the width, and then we get our squared number, right? So 5 times 5 is 25. So we find the square root of 25 is 5. We go backwards, right? So we know it because we know the area is the side times the side. A square is going to be the same number. So the area of a square now is 34 yards squared. What is the measure of its sides? Yes?
When it says measure of its sides, doesn't it mean the perimeter, all of the sides?
No.
Oh.
So, well, this would be one side.
Yeah.
So one side is 5 yards. So I think it's asking what is the measure of one side. So because they're all the same size. But now our square is 34 yards squared. Is that going to be easy to find the answer to? No, because we can't find the square root of 34 real quick in our head. It is not a perfect square number. So taking the square root of a non-perfect square requires a strong understanding of number sense. So let's examine some number sense by making a number line below. Yeah, that's what I'm just looking at. So I think we could just draw your line right there. I'm going to start with my 0 here because when we work with perfect squares, are we going to have negative numbers?
No.
No, because perfect squares are not going to be negative, right? So we know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, what's my next one? 6, 7, 49, 64, 81, 100, 121. Okay, so getting an idea of where those perfect squares fall on our number line. So we're going to estimate. So do I need to know the exact number? No, I don't want the decimals. We're going to estimate with the nearest whole number. Estimate each square root to the nearest tenth. Okay, so we're going to go just one decimal place. And locate its value on a number line. You may want to refer to the perfect squares of CO12 or CO11, so the objective before this, to use as guides. I put them on our number line. So if we look at that square root of 34, I'm going to put my square root of 34 right here. What perfect square comes before and after that? Say a little louder, Luca. 25 comes before it. 36 comes after it. So is it gonna be closer to 5 or closer to 6? 6, because we know that the square root of 25 is 5, the square root of 36 is 6. 34 is closer to 36 than it is to 25. So it's going to be a 5 point something because we're not all the way up to the 6. It's going to be close to 6. So what do you think would be a good 10th place to put in there? What would get me closer to the 6? 36. 5.8 would be a great guess. This is an estimate. So you could have said 5.7, 5.9, as long as it's getting me closer to the 6. I wouldn't want to say 5.2 because that's going to be closer to the 5. And we know 34 is closer to 36. So we want our decimal to be getting closer to that 6. Let's do another one together. 180. So this one you might want to look at. Oh, wait, we're not done. It says, and locate its value on a number line. So to do that, oh my goodness.
We have to draw a number line for every single line.
Yep. And look at the number line I'm doing. I'm just putting a 5 and a 6, and then I'm putting 5.8. That's all you have to do. You're just showing that you know it's closer to the 6 than it is to the 5. So let's do the square root of 180. So I'm going to write my 180. What is the one to the left? The closest perfect square to the left? Gus?
169.
And on the right?
196.
196. So what's the square root of 169? Yeah.
Let's see. 13.
13. What's the square root of 196? 14. So what does that tell us about our estimate? It's going to be, what's my whole number? What does it have to be, Evelyn? What does my whole number have to be though? 13 point something, right? And Evelyn, is 180 closer to 196 or closer to 169? Closer to 169. But it's kind of hanging out towards that middle, right? Because from 169 to 180 is 11. From 180 to 196 is 16. So we know it's going to be closer to the 13, but kind of close to the middle. Because there's not a big difference between 11 and 16. So what do you think would be a fair guess for our estimate?
13.
Maybe 13.4, 13 point, not Gus, sorry, Chance. I was looking at you. I just called on Gus, sorry. So 13.4, 13.3, because we know it's not going to be 13.1. It's 11 away from that 13. It's not going to be all the way down to 13.1. But we know it's not halfway, so it can't be 13.5. So you're kind of using that logic. Which side is it closer to? What would be a good decimal point for that? If the answer key says 13.3 and you put 13.4, am I going to mark it wrong? No, because it's an estimate. If you put 13.8, would I mark it wrong?
Yes.
Yeah, because that's too far going the other way. We know it can't be 13.8. Then we have to do our number line. So you're going to put your two whole numbers, 13 and 14, and we know that it's going to be less than halfway. Okay. So this is the work I want to see. I want to see your radicals, your perfect squares on both sides. I want to see you putting what the square root is of them. I want to see how you're working it out. Let's do the square root of 5 together. Evelyn,
4 and 9.
so we want the square root of 5, and Evelyn says our perfect squares would be 4 and 9. Square root of 4 is 2, the square root of 9 is 3, so that tells me what's our whole number going to be. Our whole number has to be what?
2.
2. It's got to be 2 something, because we can't go over the 3. It's in between 2 and 3. So is it going to be closer to the 4 or closer to the 9? The 4. Because the square root of 4 and the square root of 5, 5 and 4 are really close to each other. 5 to 9 is farther apart. So what do you think would be a fair guess? 2 point what? Maybe 2.2? 2.1? So then we're going to do our whole numbers of 2 and 3. 2 and 3. And we think it's going to be close to the 2. I heard somebody whispering, what's the point? Why are we doing this? Is there going to be a time where you need to estimate square roots? Yeah. In real life? Yeah. Maybe you are trying to fence in your yard and you're trying to get an estimate of how much fencing you need, and you need to figure it out, and you might not have perfect squares that you're working with. Okay, there will be times in real life that you will use this, so you need to know how to work it out. Let's look at what the rest of our homework is. Estimate each square root to the nearest tenth and locate its value on a number line. Show your work. So everything that we were just doing. So you're doing the same thing down here. Next page. Estimate what? Are we good? Okay. Estimate each square root to the nearest tenth and locate its number on a number line. Same thing. Now we're going to shift your thinking and work backwards. Woo! Backwards thinking now. So if we started with the square root, now we need to figure out how are we going to work back. So if we know our whole number is 2, what perfect squares would be on each side of the 2?
1 and 4. 4 and 9. 2 and 3. 4 and 9.
Perfect
4 and 9.
squares.
4 and 9. 4 and 9.
So are you saying the perfect square or the square root? So I'm trying to think of what to write here. So our perfect squares, the numbers that would go into the perfect square, some people are saying 4 and 9, those are our square roots because we want 2 and 3 on each side of it. So the square root of 4, square root of 9. So 2.7, am I going to say maybe the square root of 5?
No.
Why not?
Because it's more than halfway.
Because 2.7, it's going to be closer to that square root of 9. So we don't want to say square root of 5 because that's closer to the 4. So something like square root of 7. Okay, that's closer to the 9 than it is to the 4.
Do you have to write a number line for that one?
No. You have to figure out the square root. Okay, so could you have said the square root of 8? Yeah. Okay, because it would be closer to the square root of 9. So this is an estimate. It's not going to be this is the absolute correct answer, but there will be answers that will be wrong. It could not be the square root of 5 because that wouldn't have a 10th place of 7. Does that make sense? And then you're going to have to work through your word problems. You're doing the same kind of math, friends. Same kind of math. Just see, are you're find the length of a side, so you're finding the square root. Okay, it's not a perfect square, so you're just doing the same math. All right, for my friends at home, we hope you are well, and we hope to see you soon. Have a wonderful day.